Hello everyone. Today we will take a basic introduction of our subject fluid mechanics. Fluid mechanics is an important subject which is taught in civil engineering second year, and we will discuss the introduction of this subject, like what we have to study in this subject, what is fluid mechanics and what is fluid first of all. So we will discuss it one by one. Let's see. So first of all we will discuss what is fluid. So fluid is any substance which can deform continuously under the action of shear force. Like you can see in the diagram here, the force F is applied on this fluid and the deformation can be observed, which can be written as delta X. So when we apply any shear force on this fluid, this shear force may be very small and it may be constant, but the deformation continues. While if we see the solids, when we apply shear force, the deformation increases after increasing the shear force. But here the shear force remains constant and the deformation continues. So that's the basic difference between a fluid and a solid. Any gas or liquid can be a fluid, like water is a fluid, honey can be a fluid. Anything which has a property to flow is a fluid. Now what is fluid mechanics? Let's see what is fluid mechanics. So fluid mechanics is the branch of physics which is used to study the forces acting on the fluid and their effects. Whenever a force is applied, the effects related to motion, deformation, etc. are studied in fluid mechanics. It has three branches which are named as fluid statics, fluid kinematics and fluid dynamics. Let's see what is fluid statics. Fluid statics is that part of fluid mechanics which deals with the fluids when there is no relative motion. That is, the fluid is at rest. Whenever the fluid is at rest, the forces acting on the fluid are pressure forces. Since there is no relative motion, so there will not be any viscous forces. And when there is a motion in the fluid, there are two ways to study the fluid. First of all, when we study the motion of the fluid without considering the forces causing the motion, then it is called kinematics. And then if we also consider the forces that cause the motion, then it is called fluid dynamics. So in this subject, we will study our entire course in three parts: fluid statics, fluid kinematics and fluid dynamics. Now what are the applications of fluid mechanics in civil engineering? There are various applications like air pollution control. To study the flume behavior, we need to study the fluid mechanics. And water and wastewater treatment. In any treatment plant, there is a flow of water and its impurities. So we need to study the flow characteristics of water. And similarly in wastewater there is also flow of water. So we need to study there also the flow characteristics. Similarly, there is a groundwater management and control portion where we study how the groundwater flow depends on the Reynolds number. And if we want to construct any dam or a bridge, we need to find out the force exerted by water on the dam or bridge, which can also be learnt in this subject. Similarly, we can design the canal. To design the canal, we need to find out the flow of the canal, velocity of flow, similarly depth of flow and other flow parameters, which can be calculated using the principles of fluid mechanics. Now, what we have to study in this subject? So, as per the executive curriculum, the syllabus has been divided into 5 units. Unit 1 consists of understanding the fluid, like what are the physical properties of fluid and what is the pressure density height relationship, what are the manometers, like manometers are the devices which are used to measure the pressure. It can be simple manometer or differential manometer. Differential manometers are used to determine the pressure difference between 2 points. We will study all these devices, how they work and on what principle they work, we can study here. Later on we will move on to forces on due to a static fluid. Like if a static fluid is placed in any surface or in any container, then the force will be exerted by the fluid on the surface. Depending upon the surface of the container, various expressions of forces are determined. Similarly, we will later on move to buoyancy. Buoyancy, concept of buoyancy, what is Archimedes principle, and stability of immersed and floating bodies. Like what is equilibrium condition, stable equilibrium, neutral equilibrium, and unstable equilibrium conditions. In Unit 2, Unit 1 was fluid statics. Unit 2, we have to study about the fluid kinematics. In this unit, we will study the flow characteristics, like what are the types of flows, fluid when flows, then what is steady and unsteady flow, uniform and non-uniform flow, laminar, turbulent, rotational, irrotational, compressible, incompressible, subsonic, supersonic, subcritical, critical and supercritical flows. These are the type of flows we will discuss in this unit. And later on, some flow characteristics like streamlines, path lines, streak lines, stream tube, continuity equation, which is very important as per the exam for 1D, 2D and 3-dimensional flows, and some mathematical functions which are used to in this fluid mechanics motion, like stream function and velocity potential function. In Unit 3, we will study about fluid dynamics, where we learn a very important principle like Bernoulli's equation and the applications of Bernoulli's principle, like the devices pitot tube, orifice meter, venturi meter and bend meter. These work on principle of Bernoulli's theorem, and these devices are used to measure the discharge or velocity of flow at any point in a fluid through a pipe. Notches and weirs are also devices used to measure the flow of water along a canal, along a tank or along a river. Momentum equation is based on the Newton's second law of motion, which states that the net force acting in any direction is equal to the rate of change of momentum per second. And its application, we will also study its application to pipe bends, and later on we will move to resistance to flow, minor losses whenever fluid flow, what are the losses occurring in fluid flow, power transmission through a pipe whenever fluid flows, what is the value of power transmission, and one of the phenomena, water hammer, we will study in this unit. When we will go through Unit 4, we will study laminar flow and turbulent flow in little bit detail. We will study here Stokes' law, a very important law, boundary layer phenomena, what happens when the fluid flows near a boundary and the phenomena related to it. Similarly, we will study the turbulent boundary layer and turbulent flow, mixing length concept, and whenever the fluid flows, the variation of velocity can also be determined using these principles, how the variation of velocity occurs along the diameter of the pipe. In Unit 5, we have to study drag and lift. Drag and lift are the forces whenever a fluid flows over any object or object moves in a fluid. There are some forces which are acting between the object and the fluid. These forces are discussed in Unit 5. And later on, we will move to dimensional analysis. There are two methods to understand the dimensional analysis. One of them is Buckingham pi theorem, which is a very important theorem to determine the formulas on the basis of dimensional analysis. And we will have a little overview of computational fluid dynamics, which is another branch of fluid mechanics. So it was the syllabus of fluid mechanics. Now what are the books we can refer? As per the accretive curriculum, we can get maximum syllabus from the writer R.K. Bansal, Fluid Mechanics and Hydraulic Machines, and some standard books are also used to have a deep learning of the subject, which are mentioned here. Now, what is the course outcomes? These are the course outcomes. After studying this subject, these are the 5 outcomes which are expected to be fulfilled. Like we will learn the principles of fluid statics, kinematics and dynamics, which I have discussed earlier. And we can explain the terms used in fluid mechanics to describe fluid and flow properties. We will understand the fluid properties and flow properties. We will be able to classify the fluid flow. What are the types of fluid flow we can classify? Similarly, we will be applying principles of fluid mechanics like continuity equation, Bernoulli's equation, momentum equation and energy principle. These principles have also need to be learnt, and it can be applied to various practical phenomena. And next course outcome is applied dimensional analysis. Though I discussed using dimensional analysis, we can find out the formula of any physical phenomena, and it is an alternate way of determining any formula. So after reading this subject, this course, we will be able to apply the dimensional analysis also. So this was the course. Now this was the basic introduction of the subject. After that, this course, we will move to topic by topic study of from Unit 1. Like in Unit 1, we have properties of fluids. So properties of fluids are the basic parameters which are used to understand the fluid. What are the properties of fluid? Like we will use mass density, weight density, and specific gravity, and viscosity, surface tension, capillarity. These are the properties associated with fluid, and it is used whatever characteristics we are studying. Some of the property is used, like mass density is very commonly used, specific gravity is very commonly used. So in later on, when we proceed forward in this video series, we will discuss the fluid properties first of all. What are the fluid properties? Like mass density, weight density, specific gravity, specific volume, viscosity, capillarity, and surface tension. After that properties, we will understand some devices which are used to measure the pressure or pressure difference. In civil engineering, we need to find out pressure acting on any dam. So this pressure can be used to calculate the pressure force acting on any dam, and it is helpful in designing that dam because you need to find out first of all the load acting on this dam. So while designing the dam, the principles of fluid mechanics are very helpful. So that's all for this introductory class. We will meet in next lecture with properties of fluids later on. Thank you very much.